All right, so these two rules made up probably a third of the test. Just these two rules. First rule is what rule? And that was the problem. Yeah, and again, a lot of people weren't using the paper, so when we practice, I would practice just like you're going to do the test. Have your paper out, whatever you will have out for the test. You'll be using worksheet, the rules sheet, have it out. Like we tend to just try to wing it on the test day, or wing it at least on practice, and then try to figure it out on test day. That's too late. This was the sheet. That has all your rules. Every rule you needed, assuming that you were here when we wrote the last rule on there. It is what math going on in there? What's the math going on in the problem itself? Not in the problem, it's not. In the problem, what's the math in that problem? Multiplication, right? Is that what you said the first time? I didn't hear you. So then when the problem has multiplication in it, the answer has addition in it. So what's the first thing we do to write the answer? Some people even miss this. You said it a million times. It's the first thing we do. What? Come on, I said you can always say this whenever we're dealing with this topic. First thing you do, the answer. This is the problem right here. Write the base. Yes, write the base. Some people didn't even get the base right. You write the base. I gave some points for that. If you didn't do anything else. So now that you have the base, now you take the exponents and you add the exponents. What do you also have to do though? Thank you. Well, not subtract. What are we missing up there? No. There we go. Is that Aubrey? Yeah. All right, Aubrey. You told Aubrey. Which doesn't really make sense to me because you're not shy about saying answers. So this is for Miss King. She left you word. So I will believe collectively. So those of you that are just messing around, I don't know how she's going to grade it. So she left it for you to do. So do with it what you will. So I'm just going to hand you guys a stack. Oh. If that's not enough, I've got plenty of them up here. But I think that's good. All right, so we need to write a 1. Not a lot of people forgot that, but definitely a few forgot that. So now, now a lot of people didn't do this next step. A lot of people didn't show me the work, so you lost points on that. Whether it was right or wrong, you still lost points. If it was wrong, you lost all the points. Because I specifically said on the test, show your work. So 3 is the base. And then when we add all of those up, 1, which you could just write as 3 without the 1, but if you left the 1, that would be 5. So we didn't do horrible on the ones that were the multiplication rule,
What did we do better?
the product rule. This next one, and different versions of this rule, I should say. So yeah, and that's what I don't get. This is not a hard problem. I had one up on the board exactly like this. So, well, not substitution. It's quotient rule if you're trying to name the rule. This was the quotient rule. We said write the base, and on the sheet, it tells you right on the sheet, you take the exponents and you subtract them. Top, subtract the bottom. Now, a lot of people got this first answer. Oh, yep. So a lot of people got that, but either you didn't hear me, and I said it multiple times, or you didn't read the directions. You can't leave it. That's not the final answer. The final answer is to get rid of the negative exponent. We cannot leave a negative exponent. And I had a problem just like it up on the board, which is why, yeah, it's not difficult. You write 1, that gets rid of the negative, so now the negative is gone. So now you just take the base and the exponent, and write it underneath the 1.
How did you know this?
I don't know. And it was bad. I mean, I don't even mean like barely failing. It was like average of 25, 30%.
But I still have to make this up from Thursday.
Yes, yeah, everybody's got to make this one up. So it's such a low average. Yep.
No, I'm saying like since we're retaking, do I have to make it the 1?
Well, you're not nobody's retaking.
No, he wasn't.
This is for the big quiz. I said the big quiz it will be on, but yeah, you got to make up the extra.
Okay.
Yeah. So you'll see it twice. Everybody else will still see it one more time on the big quiz. Because the big quiz is nothing but exponents still. No, we're adding more to it. So that's what I'm going to do a little bit of today. It's the same exact thing you did last week. And then remember how I started where we had variables like an x and the exponents, and we had to solve for the x. Oh, I don't know if you were here with that. Right? You never did. So you'll see it today. I'm going to go over it today. So this one right here, along with even a positive version of that, so where you came out with a positive exponent, but you had multiple answers you had to select from. I mean, I want to say only about 10 people got that one right out of 100. It's the same exact thing. You take the top number, you subtract the bottom. I don't know why so many people missed it. Again, maybe this was confusing, but this right here is not the same thing. So is not the same thing as what that symbol means. That is not the same thing as this. A positive exponent and a negative exponent are different numbers. The one on the left would be 1 over 9 to the 4th. The one on the right is obviously 9 to the 4th. So I don't really understand where the disconnect was. I mean, we did problems like that. I said you're going to have to choose. I told you you're going to get a multiple choice problem. I'm going to ask you which answers are the same value or equivalent to this one particular number, and you had to choose them all, and we didn't choose very well on those. Like I said, there may have only been 3 or 4 people that got both of the multiple choice right. Any questions on those two? I'm going to do a little bit of a new lesson, and then I'm going to just let you practice, which I would imagine I'm not going to be super strict on it, but I want you to do at least a couple when I let you practice. It's going to be a pretty easy day today. We'll start a little bit more normal tomorrow after all the testing. Well, not tomorrow for you guys. Thursday. No exit ticket this week. So we're just going to practice for the big quiz.
When is that next?
Well, remember, next week is a weird week because we're off Friday. So that means Tuesday, I think we're getting rid of the skinny day where you have all your classes in one day.
What?
So Monday, you're going to have your 1st, 3rd, 5th, and 7th.
Is that only for that
Tuesday, just a normal Tuesday. Yeah. Only that week because we're off Friday, so you only have 4 days. So they're just getting rid of the skinny day. So Monday, you'll have all your odd classes, basically. Tuesday's just a normal Tuesday, and Thursday just a normal Thursday. And then Wednesday will be a normal. So the only day that's different is Monday. Monday is the only day that's different. You'll go to all your odd classes only, and you'll be in there for a block.
You're just switching Friday.
Basically, exactly. We're just moving Friday to Monday. That's exactly right. All right, so let's do a little bit of the new material then.
Why do we?
Oh, shoot. No, this was one that people didn't do.
Why do we have?
I don't know.
Don't you guys do 3 times?
I thought originally it was for Good Friday, but I think Good Friday was not. So I don't know. But we're off. That's all I know. Teachers are even off. It's not like it's a teacher planning day or anything. We're even off. So this one was one that was missed a lot too. I mean, this wasn't a specific problem, but this concept. These are different numbers. They're different answers done in a different way. Everybody wanted to take this one and do the 1 over thing. There's no negative exponent, like, take away the negative exponent. There's no negative exponent here. I mean, I would say at least half the kids did this on this one. There's no need to do that. That is to get rid of a negative exponent. There's not a negative exponent in here. There's not a negative exponent out there. There's no negative exponent. There's no need to do that. Over here, we need to do that. And we'd write it just the same exact way underneath. So literally everything's the same except we take away the negative and we write 1 over the original number. But for some reason people did this on this one also, which is wrong. And again, that was probably half the people tried to do it that way. I don't know why. So make sure you understand, this is not it. There's no need to do this. No need. What would you do on this one on the left? Yeah, you just figure out what are the exponents. In this case, they're all 1. So you'd multiply 3 times every one of those. So that's just 4 to the third, a to the third, b to the third. That's it. All right, now let's get to the new stuff. I forgot I was going to go over that one. We don't need that anymore, I guess. There weren't even, I didn't even put any real difficult ones on there like that, so. All right, here we go. So I'm not going to go back through the whole lesson because we already did this once. I'm going to kind of review it, but I'm not going to like ask you a bunch of questions on stuff we already did. So again, we have the product rule. There's multiplication. Oh, and please take notes on this. Like, you're going to be lost on the big quiz because a lot of you are already lost, apparently, based on the last exit. So make sure you have these notes. Anybody that wasn't here today, or I wasn't here yesterday, but they're going to have to go back and watch the video. Hopefully they already saw it once last week, the same thing we did last week. But you guys are going to have a little bit of an advantage that you get to see it again. And hopefully take it more seriously. So when you have multiplication in the problem, if you have the same base, which we do there, and then we do in the bottom one, you add the exponents. That's the same thing we just did. So the answer is 3 plus 7, or 4 to the 10th. So this is, again, I'm not sure where it's confusing, so if somebody's confused, please speak up. The exponents have to add up to this. Like, that's how we got that answer on the far right. The exponents on the left added it up, and I'm going to call it the, Gwen, put that down, please. The answer exponent, I'm going to call the exponent, actually, let's highlight it in color. The answer exponent is the one in black. So the answer exponent is 10. The problem exponents are in red, the 3 and the 7. This is the rule every time, and I don't care what different exponent rule we're using, you use the exponents in the problem to come up with the exponent in the answer. Sometimes you'll add them like here, sometimes you'll subtract them like if we do the quotient rule. Sometimes you could multiply them if we do the power rules. But regardless, you take the exponents in the problem, not the base. Did I do anything at all with the base to get that 10? Still 4, right? 4 is just 4. Never use the base. I just take the exponents, I add them together, they got 10. So I'm going to do the same thing down here. I use the exponents, I add them all together, I need to write a 1 in on that one. 13 is just the base, I don't really need to do anything but write that. Add all the exponents. And we get 13 to the what? 9, 10, 5. So again, the exponents in the problem add up to, I don't want to use that, add up to the exponent in the answer. Again, we're using addition because we have a multiplication problem, but if it was a division problem, a quotient rule, we would have subtracted the exponents. If it was a power rule, we would have multiplied the exponents to get the answer exponent. But regardless, you use the exponents on the problem side to get the exponent on the far side. Now, when we have a variable as the exponent, nothing changes. Still the same problem. We're using the exponents on the problem side. So the exponent on the problem side to get the exponent on the answer side. Well, in this case, we're using multiplication, so we need to add the exponents on the problem side. And that gives us x equals 2 plus 4, x equals 6. Hey. Kings? Yeah. Jocelyn? No other one to Jocelyn. Huh? Not yet, at least. So, wait, who, Jocelyn who? Oh, okay, because I saw one of my Jocelyn earlier. Olivera? Okay. So we take the exponents on the problem side and use them to get the exponent on the answer side. Same thing in the next problem. Take all these, add them all up. Since it's a multiplication problem, x equals 4 plus -8 plus 5 plus 6. X equals what? -4 plus 11. X equals 7. And I'm going through that fast because you already saw it last week. Yes, sir. For what? Try to get past from that. Tell you what, you're not my student. I'm going to blame it on Miss King. All right, so any questions before we kind of get into the exponent now moving around? And I don't know why this all of a sudden makes it harder. Well, here it's in the answer, right? So we're really just doing the same thing we did before.
It would just be in a different spot. Like
Yeah, it's going to be in the problem side instead of on the answer side. So, for example, these two problems. So I want you guys to go ahead and write the equation for how you would, where would the x be basically in that? So go ahead and write the equation. What you think? If I said solve for x, which I kind of said what does x equal, but basically that's solve for x. Write down what the equation would be, not just what x equals, but what's the equation? Because it's going to get tougher, you know. I'll give you a minute. Oh, yeah, forgot. All that happens is the x just moves around. Sometimes it'll be on the problem side. It actually will really never be on the answer side. It's always gonna be on the problem.
Can I tell you the answer to the first one?
Yeah, you can. So again, I'm going to go through a process, even though these are pretty simple, but this is the same process you would use on the more difficult problems. You need to circle the exponents. I mean, again, I won't take points off, but I'm just saying if you are struggling, circle the exponents on the problem side. The exponent is everything that's raised up above the base. In this case, it's just one thing. But when we get to the more difficult problems, it will be more than one thing. And then use those exponents to come up with the exponent on the answer side. Again, whatever's raised up above the base, that's all the exponent.
The second one's 4.
That is correct. So the equation would be 2 plus x equals 9, because in this problem we have the product rule. So we would add the exponents in the problem side to get the answer exponent. So if I were to solve this, again, it's not hard to figure out what x is in this one. You know what number added to 2 is 9. To solve it, though, if you remember our equations, we want to get x all by itself. That's what solving means. Get the variable by itself. So that means we need to get rid of that 2. Well, if we get rid of the 2 there, we need to get rid of the 2 there. Whatever, remember, my most important rule, whatever we do on one side, we have to do the exact same thing to the other side. And then that means x is 7, which again, it was pretty easy to figure out what that was. So now the next problem, use the exponent on the problem side, exponents, to get the exponent on the answer side. So 4, and we're adding them again because it's still the product rule, equals 16. Don't need the base. You'll notice I'm not writing the base anyway, because the base doesn't change. It's always going to be 8. So there's nothing we need to do with that. Just 8 on the problem side and the answer side. So to solve that, that's just a 2-step equation. I want you guys to try that one. The one that I just wrote at the bottom one. We already solved it.
I already solved it.
Yeah, you did. I'm just doing that for people that didn't solve it. Did you solve it using that, or did you just figure out what it was? Did you write an equation, or did you just figure out? Yeah, so you need to know how to write an equation, as you'll see in the next one. This is half the points on the problems, by the way. if you just set up the equation, even if you can't do the math, that's half the credit.
What would you do after that?
I'm gonna go. It's a two-step equation. How do we do a two-step equation? It's the same way you solved it on your own. You just didn't write the equation.
Oh, it is.
So what's our first thing we do in a two-step equation? Albert. Yeah, again, we want to get x by itself. That is the process for solving for a variable. Just get it by itself. That's all you got to think. Well, to get it by itself, I'm going to have to get rid of 4 and 3. I always want to start with the one that's just a number. I don't want to start with the 3 that's next to the x. That'll be the very last thing I do is get rid of that 3. So to get rid of just a 4, I just subtract 4. If you have 4 apples and you want to get rid of them, subtract them away, take them away. There. So if I do it on one side, I got to do it on the other side. That gives me 3x equals 12. Your last step is always division, at least in this class. I haven't given you really any other types of problems you have to worry about. You might get some different ones next year, but even then, mostly it'll be division. So if I divide both sides by 3, that's how I get rid of the 3. 3 divided by 3 is 1, so it goes away. And then 12 divided by 3 means x equals 4. So a lot of you just probably figured that out if you solved it out. But you need to know how to write the equation because you will not just be able to figure this one out. Whoops. So do that one in red now. Mainly set up the equation. Like I said, that's half the points right there. Same exact thing we did. There's just more stuff in the exponent now, but it's the same concept. The exponents on the problem side have to get you to the exponent on the answer side. And in this case, it's still multiplication in the problem, so we're still using the product rule. So I want to see what you write. I'm going to do probably 2 more and then we'll be done. I mean, I want you to practice because you have problems like this, but since you're way ahead of the classes yesterday, I'm probably not too much. It's for your own benefit to practice.
What if you think you're good on?
Again, I'm not grading anything today because you're one day ahead of yesterday's because they didn't get any lesson on review or anything. So I'm probably going to do this with them tomorrow, which will be you guys work. But I'm going to make them work on the worksheet. So I'm going to make you guys mainly work on Friday.
Thursday?
Oh, Thursday for you guys, sorry. Yeah, so they'll have tomorrow to work and then Friday to work. You'll have today and then.
Just do the same thing.
Yeah, it's the same exact thing we just did. Same rule, still product rule. It's just there's more stuff in the exponent than just one thing. Now there's multiple numbers or variables in the exponent. Make sure you are getting the correct setup. That's the biggest thing on these problems. That will be half the points on the problem. If you do not show that on the quiz, that will be wrong. I will mark it wrong if you don't show your work and you just write an answer down.
There's one of them. Look at this up. Go back to the one. Yeah, testing, yeah. You put good testing.
So hurry, hurry, hurry.
Who is that?
I don't know. They're probably not going to let you in. Take that pass to them, and with that pass they made, I bet they don't.
So again, I'm going to show you the entire process I would go through if I were you. I won't take off for this first piece of it, but if you don't show your work and you don't set up the equation, I will for that. So I'm going to go with that same concept. I don't want to use that color. The exponent is all of that. That's the exponent for that 51. The base is 51. The exponent is all of that I just circled. So I would circle the exponent. The base is 51 here. All of that is the exponent there. That is one exponent. You have to think of that as one number. It's got two terms in it because we don't know what x is, but it's really, if we knew what x was, that would add up and we get one number there. You can have a seat anywhere in the back. So then we're going to use those exponents. Again, you have to think of that as one number. Everything in the circle is really going to add up to be one thing. And then that is one number there. You could have multiple things in the answer exponent also. They may put a variable and a number in the answer exponent.
Set it up just like that, how it is.
So this is the way now I won't take off if you don't do the circling thing, but I will take off if you don't do this next step correctly. So you need to think, all right, we're multiplying, so that means I need to add the exponents. This is one exponent. So you write down that exponent, 2x plus 1. You got to think of that as one exponent, everything in that circle. We need to add that to this exponent. Is that the door again? And then that's going to equal the answer exponent. So that's the equation you should have.
You combine terms.
Now to solve it, that would be the rest of the points. So to solve it, you have to find like terms. Well, we've been a while since we've done that, but like terms mean you have either the same variable, which we do there, or you don't have any variable at all. At least that's what it means in this class. Next year, it'll mean there's other like terms next year. But for this class, let's just focus on this particular big quiz. Same letter means like terms, or no letter at all means like terms. They're constants. So when we combine those, we would say, well, that's just 2x plus x, which is what? What's 2x plus x? It is 3x. If you have 2 x's and I give you another x, you have 3 x's. Simple as that. Think of it as a physical thing. You have 2 x's. I'm giving you one more. I'm adding one more, so you have 3 x's.
Oh, that's what I did do. I just did 3 plus 1. But I didn't do nothing with the 2x.
Well, you can't. No, I'm not combining these. Make sure you understand. I'm not adding these two things. I'm adding these 2 x's and this x over here. Don't think that I just added these two things together. So make a note. I did not add 2x plus 1. You can't add those. You can't add something that's a variable to something that's just a number.
I'll talk about the 3 and
And then we add the 3 and the 1 because those are like terms as well.
1. I just forgot to do the first part with the 3x. I just got this 2x.
Well, no, because you had an x. Remember, technically there's a 1 in front of that x. But even again, just think of it as a physical thing. If you have the number in front of the x, just tells you how many x's you have. So if you have 2 x's here, clearly I have another x here that I'm adding, then I have 3 x's. That's all the number in front of a variable does. It just tells you how many of those variables you have. And then that would equal the 23. Now you have a two-step equation. You would solve that. You would say, again, we leave this 3 for last, but we want to get rid of the 3 and the 4. So first we would subtract 4. I'm going to bring it all the way over here because I kind of ran out of room. And this one does not come out to be a nice round integer, so there's no way you would have guessed. So that winds up being your final answer. X equals 19 over 3. You're not going to guess at that kind of an answer. That's why you have to know how to set up the quickly, because we're still, I have a new rule. Not the next one. Change phone out. Good try.
You're such a bully to me. Where's the pass even at? Where's my phone?
Is there no pass over there?
No.
Tell me while the sub was here.
I don't know why you're surprised.
Well, I left her a note saying, please make sure they're going to pass that.
You think they know that?
Well, she should have, or he or she, whoever it was. All right. Oh, here it is. All right, so do the next problem, the one down here in black.
Where?
I'm gonna put a, so this is the next problem down here. Oop. So that's the next problem down there. Here, we'll use a fancy pen. Fancy pen. Let's use that one. What's that? I'm gonna leave it up in case people are still writing. I didn't really write very dark, but that's fine. That's the next problem. Main thing is make sure you write the correct equation.
That's what I did.
Yep. That's half the points, even if you can't. And you're bound to get some points when you solve. I mean, everybody winds up getting some points by subtracting the right thing, or dividing the right thing at some point. So I would maybe practice going through that whole process, circling the exponents, so that you know everything in the circle is just counted as one exponent. I guess I should do attendance. Red. Oh, actually, I guess that better.
Are you taking off for math? Like, you do math?
Yes, on the big quiz, I take off for math. So you need to practice your math too. Still not a lot. Like on an exit ticket, I sometimes wind up not taking anything off for math. Or very, very little. On a quiz, I mean, I expect you to be able to add positive and negative numbers. It's not like I give you fractions or decimals, I get just integers. You know how to add in. What is today's date? 5th, right? So try to solve that out once you get it set up. That's pretty similar to what you'll see on the quiz right there. I mean, if you can do that one, you're in pretty good shape for this particular rule. Then you have the quotient rule, which is a little tougher. The math's a little tougher. Setting up the equation's not really. And agents here. Here. Morse here.
Can you come check my work?
Yeah, hold on just a second. I did not. Where's my glasses? Oh, right there. All right, so it should be done by now. Again, the set. Well, actually, the solving. I'll look here. Too many of you are thinking that you got it, and then when it comes exit ticket and quiz time, you don't got it. Apparently, that's a new watch. People love playing new stuff. New phone, new watch. I know you got me working pretty hard on it. Every time I look up, it's around.
What's the snake?
Snake. All right, so again, I will not take off if you don't do this first step, but I think it helps organize it. Now I am, oh, can I do this? Yeah. So now I am going to go ahead and erase everything. So those are the exponents in the problem, which we will use to get the exponent in the answer. So it's a multiplication problem, same base, which means we add the exponents. So that's one exponent. I want to add that one exponent to the other exponent, which is x plus 7, and then that equals 20. The answer, exponent. Again, didn't do anything with the 33 in the base. Don't need that, because the base is just always the base. So now you solve it out. Like terms are the variables, like terms are the numbers.
9x.
So 8x, again, if you have 8 x's and I give you one more x, you have 9x. That is correct. No. So plus 2. Again, negative 5 plus positive 7 is positive 2. A lot of us are really struggling with adding simple positive and negative integers. I expect you to be able to do that. Even though you're not in my class right now, you are in my class. Yeah, but you don't need it. Back it up. You may be Miss King's student, but you're in my class. You know. You can be on your phone, so at least you get that. More than, hey, that's more than you'll get when I see you 6th period, right? Now I know you're here. So that equals the exponent. That's the answer. Now you have a 2-step equation. So you solve a 2-step equation. Get rid of the 2. So subtract 2. I guess I can kind of subtract 2 here. So that would give me 9x equals 18. Divide by 9, divide by 9. Should have gotten x equals 2. Again, if you're not working it all the way through and coming up with the answer, and this wasn't too bad, so hopefully a lot of you did, you can still get a good grade on it if you do the setup correctly. So if you did this part correctly, and then if you get some points in the middle of the solving, you'll be all right. Because there are going to be some where they won't be that. Like this is the hardest thing you'll see on them. So if you're able to get this one mostly correct, you should be able to get 100% on some of the easier ones, hopefully. Especially since you just saw it last week and this is your second time seeing it on quiz. Any questions? Again, this was the rule that is the product rule, which is why we kept adding the exponents to get the answer. We're about to change that. The math's going to get different. Same concept. You take the exponents in the problem.
How do you know which way to do it?
You look at the rules. So your rule sheet will tell you the setup. Like you see how this looks, right? It's got a multiplication symbol. Doesn't this look way different? Does that look like those other problems we've done? No, right? So what rule is that? You'd look at your rule sheet, figure out what rule that is.
You just subtract it.
It's the one we did for the bell work. It's just now we have variables in the exponents instead of just numbers. But it's still a division. It still looks like a fraction, right? We have a number over a number.
Minus 2x.
We'll go ahead and try to write the equation. Everybody try to write the equation. So again, now you have multiple terms in the exponent, but it's called the quotient rule. Still the quotient rule. This looks like a fraction. So when we have the quotient rule, we said in the bell work, we subtract the top exponent. Well, we take the top exponent and then we subtract the bottom exponent. You're going to do that same thing. It's just now you got more stuff in the exponent.
Yeah, now it's even harder.
It is harder, which is, again, the good thing about it, setup is still half the problem. So if you get the setup correct and then you don't do the math correctly, you still got 50% credit. Probably more than 50%
Is
because
that the answer?
you'll get some. That's not what x equals, but yeah, 22 is the exponent on the answer side, yeah. Same exact thing that you did in the last problem, you do in this problem. Except, instead of adding exponents, you subtract. But we're still going to circle the exponents.
It'll be 3x. That's 5.
Yes, correct. Yeah. I'm having to go over it in a minute. Tell me you're done. Try to solve out for the x too. Don't just. Now again, this is a different rule. This is not. We're not adding exponents to this because that was the product. Now we moved on to the quotient. Yeah. Now we move to the quotient. So we don't add the exponents in this type of problem.
Keep running into one.
Right. So I'll give you another minute. So now we're on to a different rule. So go ahead and try to write the equation for that and then solve the rule. How am I going to handle that?
It'll be 3 x, right?
So yeah, make sure you bring that back, please. I'm not going to require. Yeah, it was actually over here.
It'll be 3x.
I'm going to go over here. You can compare. Well, actually, I don't know if Bobby finished it. He had done it the wrong way first, but then what did you get? And I think the math in this is tougher. So it's
You do better.
more difficult. See that? Because we're not. This is not the product rule. We don't add the exponents. We add the exponents and it's the product. Here, what should we do? Yeah, remember, just like the bell work. Doesn't matter that there's more stuff in the exponents. We still need to subtract the exponents. All right, I'm going to go ahead and go over this one because we need to do another one. I can tell already. So first step, I would still circle the exponents, and this is maybe even more important in the quotient rule because the math's a little bit trickier. What is the rule for the quotient rule? Like as far as what do we do with the exponents?
Subtract.
We subtract. Good. We don't add them in this. A lot of you are still adding them. You got to remember when you change rules, the way you get the answer, the answer exponent is different. So,
Mr. Gill,
yes.
the answer is 7.
No.
It's 22.
Well, he's saying the final answer, what x equals. I think you may have added them, unless it still comes out to be 7. Because Derek got 7, but he added the exponents. So these are the two problem exponents, right?
3x.
This is the answer exponent. We are going to use the exponents in the problem to get the exponents in the answer. But we don't add them. We subtract them. But here's the...
Next to each other?
Well, this is the tricky part in these. It really is the hardest part of these, I think, is the math. So that's one exponent. You have to think of that as an exponent. That's one exponent, but we're going to subtract that bottom exponent. You have to put parentheses around it. Because that's one thing. If I just write this, I'm saying that I'm only subtracting 2x. I'm subtracting 2x and I'm subtracting the plus 3 because you got to think of that as one thing. So if we're thinking of that as one thing, we got to put the parentheses around. We didn't have to do parentheses in the addition problems because it doesn't affect anything. Parentheses don't affect anything. We could have done that. That would have been like mathematically correct, but it wouldn't affect the answer. You still get the same answer.
3x.
Not the final answer. There'd be more to it, but that's the first step. You'll see in a second. Then we would say that has to equal 22. So this is the tricky part. You got to remember to put parentheses because you're treating that as one thing. Now, when you go to do the math, again, it's a little tricky. We've done this before. So we would say still 5x plus 4, but we're actually subtracting both of those things.
Why would I?
Just subtracting them. So I'm going to get rid of the parentheses. You're kind of using the distributive property, really. I'm going to subtract 2x, and I'm going to subtract 3. Really, all you do is you wind up flipping the sign. Whatever the signs are in the parentheses, you wind up flipping them. if you're subtracting something in parentheses.
You do that every time?
Every time you're subtracting something in parentheses.
How do you know if is it always going to be in parentheses or no?
If you have this all as one term, if you're subtracting one thing, then you have to put parentheses.
Lots of if you're just like, if the problem is the same, but you didn't have the +3 at the end of the 2x.
Then you would just say subtract 2x. You don't need the parentheses. Yeah, if you've got multiple terms in the exponents, that's when you need the parentheses. So that's a good note to write. If you have multiple terms in the exponent, that's when you need parentheses. Again, we didn't need them up here. I could have done them up here. I could have said this. I could have done that. Mathematically, that's correct. But the math isn't any different. It's still just plus x plus 7.
Yeah, multiple
Terms in the exponent. Like I could have written parentheses around those, but it doesn't change the math. So I didn't write them. But this is probably more correct, like from a conceptual standpoint. It's just the math isn't any different, so I didn't write them. It's just an extra step. Now all of that still equals 22. Now I want you to try to solve that if you didn't have that before. It looks like the answer is not 7.
You can like, if it's 5x, you can only subtract other numbers that have x in it, right?
Correct. Yes. Yeah. Nothing changes. You can only combine terms that have an x or terms that don't have an x at all. In this problem. I don't. Actually, it is still 7. That's funny. I don't know how it came out to be 7 again. Yeah. Let me drink a little bit. I'm not sure how you guys were getting 7 as a final answer before. Yeah. For that part, yep. 5x subtract 2x is 3x. All right, so when we combine like terms, we would get 3x plus 1 equals 22. I'm going to move it over to here. So there's your two-step equation.
Oh, I do, yeah. Oh, she's not here. He already came looking for her.
Put it.
Xavier. So you need to go see. You don't know. I think. Unless you're really, really in trouble. All right, so two-step equation. Get rid of the. We want to get the x by itself. Get rid of the number that is just a number first. So I'm going to bring it back up here. Subtract 1, subtract 1. Divide by 3, divide by 3. So x is 7. I'm not sure how in the world that worked out, but you should not have got. Yeah, you shouldn't have gotten 7 if you did it the other way. I'm not sure how you guys got 7 the other one.
You get that.
You add the 1. I'm holding it. Okay. You're supposed to subtract.
All right. So yeah, I don't know how you guys got 7 when you added the 2. There's one last one, then we'll stop after that one. So try to set that up and try to do math.
Am I wrong?
No, wait.
I'm right.
Added is.
Yeah, originally he added the 2 exponents, but he got 7 as the answer. So I don't know how. Shouldn't have. It should have been, if you added everything, it should have been 7x plus 7. So once you subtract 7, that wouldn't be like it wouldn't even be a.
Is there no top around any exponents?
Oh, you're right. I didn't put 1. I meant to put 1. I think it erased because I didn't. If you don't lock it. So here, let me write an exponent up there. We'll go with 5x plus 1. There, that's your exponent up there. 5x plus 1 is the top exponent. I'll zoom in. You can see a little bit better. Everything in black though, basically. Boom. There. So 99, the exponent is that. The exponent is that. The exponent is that over there. So again, make sure you write the equation. That's half the points right there. Use, again, if you have multiple things in the exponent, use parentheses to show that it's all one number, one term. Yeah, it's pretty much that's the thing. Like, you need to make sure you're organized because problems are always the same. The math's a little different, but I mean, if you have example problems that are set up like a fraction, then use that when I give you a question on the quiz that's set up like a fraction. If you have problems that are not set up like a fraction that have multiplication in them, then use the examples that we did that have multiplication in them.
You put it in parentheses?
Yes, because again, that exponent is all one number. It has multiple terms in it. You have to remember it's one exponent. So I'll give you a couple more minutes, then we'll solve it, and then we'll be done. And then we'll just do, I mean, you're more than welcome to practice today, and I'll help you, but you have all Thursday. Really more than that, because although we have a little bit of new stuff next week, so don't count on a full practice day next.
We're going to get some type of grade this week.
Yeah.
We get some type of grade.
I mean, you'll always get a classwork grade just for, but again, when you know, half of you were out yesterday, I wasn't here, half of them are out today, so I'll just probably give you a really quick classwork grade on Thursday, just walk around, make sure you're working on the usual decent grade. Leave your phone, trade your phone out, please. Give you a couple more minutes.
Do we have zeros in this or not?
I'm going to go ahead. I have no idea. I did not create the exponent to like come out nice and round and even. I don't know, that's for sure. So you're from Miss King, right? Well, but remember, if you subtract, you're subtracting -1, which is not. You need to flip the sign. I'm going to go over the math on it. You can just keep solving it out if you need to that way. Yeah, in the back probably is better. Although all my kids are here.
The part you give us is the flipping.
Yeah, that's the part. But again, I won't take off a bunch of points for math. So if you just work it all the way through, even though you did that piece of the math wrong, then you'll be fine.
I can do like the X's and subtract. It's just the second one. So basically, the 1.
And so
Oh wait, no, never mind.
concept is always the same. The exponents in the problem are going to give us the exponents in the answer. We just need to change the rule and what we do with those exponents. Well, we're not going to add them here because we have a division problem. That means we have to subtract the exponents. So this is one exponent, 5x plus 1. That is going to be subtract. I could even put that in parentheses if I wanted. It doesn't affect the math. That is subtract the second exponent, the bottom exponent.
I accidentally made the negative.
You did have a negative. Yeah, I saw that. Yeah. So that would be what we need to do with the exponents. The top, this is the top exponent, subtract the bottom exponent. Same thing we did in the bell work. That equals the answer exponent. So if you get that right there, that's half the points. Just for knowing top exponent, subtract bottom exponent. Now to do the math, again, we are subtracting both of these things. So you have to say subtract 2x, which is a positive 2x. So subtract positive 2x. Then you're actually saying subtract negative 2. If you don't remember this from, like, I don't know when you learned it, probably elementary school. If you subtract the negative, you have to flip the sign. That's the keep change flip. If you remember the keep change flip.
So wouldn't
So
the negative 2 be a positive?
correct. 5x plus 1, subtract 2x plus 2. So again, all you did is you flipped both signs. This was a positive, now it's a negative. This was a negative, now it's positive. So you just remember that. When you subtract a whole bunch of stuff in parentheses, you're just flipping the sign. That's all you do. And then that still equals 28. And now we have to solve for the x. So like term, like term, like term, like term. So 5x, I don't know why I keep coming up with 3x, but it's not on purpose.
Can you still combine, right?
Yeah, absolutely. Combine the variables, and combine the ones that are just numbers. Now this is just a two-step equation.
I forgot it's still subtracting.
Oh.
I just started adding.
Yeah, I'm not intentionally always coming up with 3. It just keeps happening. So x would equal that. And you will get some fractions on the big quiz.
Can you go up?
Yeah, it's no problem.
Oh, I'm messing.
Yeah. 28 subtract 3.
Oh, so stressful. Is this on a test too?
That.
Is this on a test too?
This is on the big quiz, yes.
Stress?
On the big quiz, absolutely. So on the big quiz, you will have everything we did last week. Like literally the same. You'll have multiple choice that are just like the multiple choice, just different numbers. You'll have the top section that's just like the top section. And then we will add in this stuff. And then there's one more new thing we still have to learn also, which I'll probably introduce real quick on Thursday. But then I'll just let you practice the old stuff, and then we'll do it again on Monday. The last new thing.
That's supposed to be a
So that's all I'm going to do for today. I'm going to go ahead and stop the recording. Let me stop it.